Okay, so now that we've gone through that general categorization of reactions that we just did, the combination, decomposition, single replacement, double replacement reactions, where we're just looking at how atoms rearrange, we're going to look at a couple more specific type of reactions that are more associated with what's happening in a reaction, like what's being used, things like that. First one we're going to look at is these things called oxidation reduction reactions. A lot of times these are referred to as, that's an R, redox reactions, putting oxidation and reduction together. In an oxidation reduction reaction, electrons move from one reactant to another reactant. So one reactant gains electrons, the other loses electrons. And this process is called oxidation reduction. The process of oxidation is the reactant that loses electrons. Okay, so the reactant that loses electrons is said to be oxidized, or the process is called oxidation. The reactant or compound that gains electrons is said to be reduced, and the process is called reduction. Now, when you're gaining electrons, you're reducing the charge, remember, because electrons are negatively charged. That's why it's called reduction. Okay, so there's two mnemonics that are associated with this. Leo goes Gur, right? Lion goes Gur. Leo standing for loss of electrons is oxidation, and Gur stands for gain of electrons is reduction. Or the other one, oil rig, oxidation is loss, reduction is gain. Whichever way you think about it, it's talking about electrons. Okay, we've seen the reaction of copper with silver nitrate, with a silver exchanges places with the copper. The copper goes with the nitrate, and the silver becomes silver metal. We have a picture of it over here. We have the silver or the copper wire in the silver nitrate solution, and with time, you can see the solution gets bluer and bluer, and the silver grows on the copper wire. The blue solution is a result of copper nitrate being blue. So as it forms, because it's not there initially, as it forms, the solution turns blue. Okay, so let's look at the oxidation reduction side of this. Right, this is a single replacement reaction, but we're worried about the mechanisms going on here. So when you see a metal with a solid next to it and no charge on it, that implies that it's the metal, like a piece of metal, shiny silver, and that implies that there's no charge on it. So we don't write the zero. We just know it. If there's not a positive charge there, we assume it's zero. Okay. And in this compound, the silver nitrate, it's ionic, right? And we have silver ions and nitrate ions. Okay. Over in the products, the silver ends up being the metal piece, so that's zero charge on the silver atoms. And here, this is a ionic compound, so the copper is the anion, so it's Cu2 plus in this case, and NO3 minus. I can figure out it's 2 plus because there's 2 NO3 minuses. So that would be 2 minuses. So I need 2 positive charge to make it neutral. Okay. But what you see here is that copper goes from 0 over here to 2 plus. So that means in order to become a cation, it has to lose electrons. So that process is losing electrons. So the copper is being oxidized. So this is oxidation. On the other hand, the silver is going from a +1 to a 0. Right? So the silver is +1 here, and it's 0 there, which means its charge is being reduced. So it's gaining electrons. So this is gaining electrons. So the silver or the silver nitrate is being reduced. Or that process is reduction. Okay, so the silver goes through reduction. It gains electrons to become silver 0. And in the copper's case, the copper loses electrons to go from copper 0 to copper 2+. If we look at a couple other of these, the reaction of sodium and chlorine. Sodium's a silver metal, but very reactive metal, right? It's an alkali metal. It's in the first column. They're very reactive. And chlorine's kind of a yellowish-greenish gas. When they react, they make the salt that we eat. Obviously, both their starting reactants would not be good for you to eat. Chlorine's very toxic, and sodium would burn the heck out of you. But when you combine them, you get a compound that is actually necessary for life. In this case, we have the sodium metal, so that's 0 charge. In chlorine gas, each of the chlorines is also 0 because it's in a single bond. When they react, we get sodium ions and chloride ions. We know it's ionic because it starts with that metal. And sodium are +1 ions and chlorides are -1 ions. So if I go from the sodium metal to sodium plus, that process is losing electrons, so that the sodium is being oxidized, or oxidation is occurring to the sodium. And the chlorine is going from 0 to negative. That means each of the chlorine atoms is gaining an electron. So electrons are being gained by the chlorine, and that's reduction. And the last one is, we've also seen the magnesium metal reacting with the hydrochloric acid. Okay, magnesium 0 here. The H as an acid, which we'll see later, is H+. And it goes over here to magnesium chloride, ionic compound, so that must mean the magnesium's ionic, and the chlorine is negative. So as the magnesium reacts, it goes from no charge to a +2 charge. It's losing electrons, so that's oxidation. So the magnesium is being oxidized. And the hydrogen, go down and around there. The hydrogen is going from H+ to H0 because it's, that's its elemental form. That's how we find it in the atmosphere at room temperature. So that's gaining electrons because it's going from H+ to H0. So that's gaining electrons, and that's reduction. So the magnesium is being oxidized, and the hydrogen is being reduced. Or magnesium is going through oxidation, and hydrogen is going through reduction. Right? So for oxidation and reduction reactions, especially with when containing ionic compounds, it's pretty easy to see where you have the metal that's a solid, and then it's an ion as a product. So the solid metal is a reactant, and it's an ionic form as a reactant. That means it's had to lose electrons, and when it loses electrons, something else had to gain electrons. That's going to be an oxidation reduction reaction.